Welcome back. We're going to talk some more about lists and tuples. What I want you to do is go ahead and type Python built-in types into your best friend, the Google, and click on that link right there. And we're going to go on a guided tour of sequence types. So we can see sequence types. Click on over here, sequence types. Okay, so we'll talk about operations and things that we can do in sequences that allow you to use wheels rather than reinventing them, because there are lots of good things that happen in sequences. So first of all, there was the in operator, and we began learning about the in operator. Let's make a list here and put a few items in it. X gets, 1, 6, 8, 2, 6, 8. True. Cows. Moo. Horses. And here, let's chuck this in here just for fun. 1, 2, 3. Oh my. You can put a list inside of a list. Oh yeah. Okay. So here's our list. Now, one thing we learned about sequences, lists or tuples, and here I'll make a tuple version of this. Y is equal to tuple of X. If you cast a list to a tuple, you get a tuple. Yeah. Okay. So now let's take a look in the documentation, and we can see the is, right? Or the in. So in works like this. Watch this. If I go 1 in Y, I get a true. That's interesting. 2 in Y. How about 10 in Y? 10 in Y. False. 1, 2, 3. In Y. Yes. Okay. How about 1 in X? In works the same, whether it's a tuple or a list. If it's in there, it's in there. Okay. Because the main difference is between tuples and lists is mutability and mutability. Lists are mutable. A lot of times you will change the list itself. Tuples are not mutable. So if you want to alter the variable, or a tuple a variable is pointing at, you're going to have to point at a new tuple. But just as with strings, you can franken build. Let me show you an example of that. Let's look at plus equals. Let's make a string S is equal to hello. All right, S plus equals bang. All right. So now we're pointing at a new string that's hello with a bang at the end of it. The original string S is still there in memory. It's just no longer accessible. Now let's do the same thing with a list. So I have my list X, and I go X plus equals, now we got to put a list on the other side, and I will put 4, 5, 6. All right. When I do that, 4, 5, and 6 go on the end of the list. The same list. Now let's do this. So I'm gonna let Z equal Y. Okay, Y is a tuple, and now I'm going to go Y plus equals 4, 5, 6. All right, here's X, here's Y, here's Z. Z is the original tuple. The original tuple did not change. When you did this plus equal operation, a new tuple got created. But when you do that to a list, a new list does not get created. The the list is changed, we say the list is changed in place, because plus equals is allowed to change the state of the list. It is a mutator behavior. Whereas down here, what happens is you get an entirely new tuple. The old one, if you wanted to keep track of it, you needed to set it equal to a variable like we did, and you can keep track of the old tuple. Otherwise, that old tuple winds up being garbage collected. Okay, so that's in and plus equals. Let's see what else we have in here. We have all the index operations that we talked about last time. We also have len. This works for strings, tuples, and lists. Min. Oh, what about min? Min is the smallest item in the list. And generally, using min or max, a smart thing to do is only to use them on a homogeneous list or tuple with items that can be compared, such as numbers. Min and max are very good for extracting the minimum and maximum of a number in a list. Okay, you also have dot index, which will tell you at what index something resides. Let's go ahead and demonstrate that. So I'm going to come in here and I'm going to say here's x dot index of 2. There's no find. You use index. Okay, so there's index and there's also count. So you go s.count of say true, and it'll tell you how many times. Oh, s.count. Oh, interesting. Must be string, not bool. Total number of occurrences. Oh, wait a minute. Oh, let me go back here. What did I do? Oh, I said x. Here's x. Let's try cows. There we go. Let me try x.count of true. Yeah, there we go. So it'll tell you how many times something appears in the sequence. That works for lists and tuples, and it also works for strings. If what you pass in is a string, it'll count the number of times that substring appears. Okay. Now below here, you can see examples at work. Now here we have a little more detail for lists. So we can, as we saw, elements of a list are L values. You can assign to them. You can also assign a slice. This is called slicing a list. If you assign it to another list, those items will be inserted in lieu of the slice which you deleted. There's something called del. I usually do the thing on the right, and that deletes entries between index I and j. Okay, you can also do something like this, where you have a skip factor in. I seldom, if ever, do that, unless I'm actually trying to delete entries. Append puts things on the end of a list. So I can go x.append, and then you don't pass in a list, you pass in just an object. So I'll append cats, and x will now have cats all the way at the end. Okay, so that's, and then there's extend, but extend is the same thing as plus equals, and plus equals I think is more idiomatic. You can multiply a list by a number. So let's make a smaller list here. I'm going to abandon this great big list. I don't know, A, B, and then 42. All right. And it repeats, okay? You can remove things from a list. Let's try x dot remove of 42. Item. And reverse does the obvious thing. It reverses the list in place. So, pop will also remove something from the middle of the list. You can insert, you can pop. So you can insert something at index I, or you can pop it. All right. So all these operations are possible on lists because lists are mutable. None of these things can be done with a tuple, although s plus equals can be done with a tuple. Okay, and then there are some notes and caveats down here. You might want to look at those. Okay, lists have some services. You can sort. Okay, you can sort, and if you specify reverse equals false or reverse equals true, it will sort in reverse order. By default, reverse is false. Now here's the tuple area. All right, and tuples are like lists, only you cannot change them in place. And you can make tuples a number of ways. You can make a pair of parentheses as an empty tuple using a trailing comma for if you're making a singleton tuple, you use a comma afterwards. Otherwise, it just thinks A is in parentheses. You can omit the parentheses if you want, and you can also use tuple on a string or on a list, and you'll get a tuple out. Now, one sequence type I didn't talk about is range. But range is pretty straightforward. Ranges are interesting because they're not really a data structure. They're a rule. And if I go A is equal to range of, say, 1 and 11, that's not very descriptive. But if I go list of A, I can see what items are in here. So starting at 1, ending before 11, I get an arithmetic integer. And this only works for integers, an arithmetic integer progression. So a range is a rule that walks through the numbers. This range is a rule that walks through the numbers 1 through 10, but casting it to a list produces an actual list. And you might ask, well, why would you do a thing like that? Well, this object could be rather hefty. You know, if we made this into a list, you've got 1,000,000 integers sitting in a list. It's humongous. But the range is a smart little creature. It just says, okay, I'm starting at 0, and I'm just going to keep going up by 1, and I'm going to stop before I get to 1,000,000. And that rule is much more lightweight than a great big list. So the range object is actually an example of what's called an iterable. Iterable means repeatable. And later on, we'll see how to use a looping procedure to walk through any iterable that you create. So that's the range, which is also a sequence type, and it's got 3 arguments: start, where to stop, stop, where to stop before, step, or I like to call it skip, how much to skip. And you should take a look in these examples and see what they look like. Now, I also said that strings can be regarded as sequence, and most of the sequence operations work on them. And then they get down into the string methods. So now you've seen the complete story on lists and tuples. I encourage you to go through, create examples, experiment, try things, see what you think. And I'll see you next time. Let's go ahead